Good day. Just want to make sure I'm sharing the correct screen. Today is Tuesday, the 15th of December 2020. So just to frame the lesson, we've spent the last 5 days on solving rational equations, and that's what your warm-up will be. We're going to spend 2 days on the next topic, which is solving polynomial equations. And I'll just talk about what we're doing the rest of the week. So today's assignment will consist of 2 examples. I'll take you through the procedure in the first example, complete problems 1 through 4, and the exit ticket. The homework assignment I actually posted this on Friday. That's due tomorrow. And Friday we'll be doing an Edgelastic assessment. It'll be on the last couple of weeks, 10 multiple choice questions on rational equations and these polynomial equations we'll cover today. So we're going to start with this warm-up, this rational equation that we're going to come back and solve, and I will come back and go over it. You should be getting 7/13 as a solution. So to kind of take you back here, when you look at the polynomial equation, as I've told you in the last 2 lessons, you want to, in these type of problems, always factor the trinomial. And usually these 2 denominators are going to be the 2 factors of the trinomial, which they are. So as you can see what I did here, x squared plus 2x minus 24 factors to x plus 6 and x minus 4. So since 3x already contains x minus 4, we multiply 3x by x plus 6. And since 4 already contains x plus 6, we multiply 4 by x minus 4. Down here, we just do the distributive property, set it equal to 3x squared minus 4x minus 2. And with these type of problems, after you apply the distributive property, 3x squared is going to cancel. So quadratic terms should cancel. And then you're just going to go ahead and solve accordingly. And I got 14/26, which is 7/13. So on the decimal, that is 0.538. And if we check our solution on Desmos, okay, 7/13 is 0.538. Just want to make sure you plug in the function in. And to find the x-intercept, just set it equal to 0. So I'm going to just change this to a minus. We see that our x-intercept is the same as the solution. Okay. So getting back to where we're going today, we're going to be solving polynomial equations. And here is just an example that you can kind of read through. I'm going to take you through the process right now. So we're going to start with example 1. Okay, so in these type of problems, what you want to look for first is the greatest common factor that's stated up here. So your greatest common factor is always going to be the variable with the lowest exponent, because all 3 of these terms contain x cubed. So what we're going to do is we're going to pull x cubed out of all of these. Okay? And like any equation we solve with the greatest common factor, we divide all three terms by the greatest common factor. So we're going to divide x to the 5th power divided by x cubed. We're going to divide 6x to the 4th power divided by x cubed. And we're going to divide 7x cubed by x cubed. So we end up with x cubed. Now, x to the 5th power divided by x cubed, all you got to do is subtract the exponents. 5 minus 3 is 2. 4 minus 3 is 1. So the second term just becomes 6x. And the third term becomes a constant. So the whole idea here is to get a monomial in terms of x and then a quadratic a polynomial that's a quadratic, because we can solve the quadratic when we apply the zero product property. We can solve that through factoring or the quadratic formula. So the next thing we do is we apply the zero product property. X cubed is equal to 0. And x squared plus 6x minus 7 is equal to 0. So x is equal to the cube root of 0, which is 0. So one of the solutions on all of these should be 0. And then the factors of -7 that add to 6 are -7, -1, because the sum is +6. So it's +7 minus 1. And then just set both to 0 and solve for x. Just erase this. I want to start over here. So the two other solutions should be -7. Let me get this down. And +1. The best way to check this is on a graph, because your graph's going to find your intercepts. So your three solutions are 0, -7, and 1. So if you look at the graph of this, so over the Desmos, no changes. And here we go. So you got, obviously, if we change this to -0, you're going to see the intercepts more clearly. -7, 0, +1. Okay. So what you're going to do next is try example 2, and I'll be back to go over that. Okay, so your three answers here, first of all, let's start there. 0, 8, and -4. So one thing on the notes we'll mention is, in a polynomial equation, as I've said time and time again, you have to set the equation equal to 0. So just use the subtraction property to move the 32x to the 4th power over to the left. And the greatest common factor is x to the 4th power. So we factor out x to the 4th power. X to the 6th power divided by x to the 4th power is x squared. So you're just decreasing all of these exponents by 4. 5 minus 4 is 1. And then 32x to the 4th power just becomes a constant. And the factors of -32 that add to -4 are -8 and +4. So your three solutions, x to the 4th power is equal to 0, so x equals 0. X minus 8 is 0. So x is equal to 8. And x plus 4 is equal to 0, so x is equal to negative 4. So check your solution on the graph. Set it equal to 0 and find the x-intercepts. So everything checks out. Okay, so we just make a little bit of a note here. So what you need to do from here is problems 1 through 4 and the exit ticket. Okay, so these problems are very similar to what you saw in the first 2 examples. I will be in touch to review this with you. Thanks.